Hi, welcome to AP Daily Computer Science Principles, Topic 3.9, Developing Algorithms, Video 3. My name is Bradley Bearden, and I teach computer science in Dadeville, Alabama. And I want to invite you to invite a friend to take computer science. So what will we learn today? We will be working with modifying existing algorithms. So we'll take existing algorithms and we'll modify them to meet our purposes. So, and then I want to point to the exam reference sheet for robots, and you need to make sure that you can work with these commands for getting the robot on the grid of squares to the right location. So let's look at an example. So this is the famous collapse conjecture. So I start with a positive integer, so in this case 6. If that number is even, you'll divide it by 2. If that number is odd, you'll multiply by 3 and then add 1. And then you will repeat steps 2 and 3 until you reach the number 1. So you see here, it starts with 6, and then eventually following these algorithm up here, it makes its way to 1. Now, I want to point out as a side note, because this is my favorite math problem, that it's unsolved whether or not for every positive integer, you'll eventually get back to 1. All right, but that's just a side note, so let's look back. So how can we create an algorithm where I can start with a positive number in or positive integer in, and then get the full sequence of numbers that will result from following the rules for the collapse conjecture? So first you might think, is there an algorithm that I could start with based on the rules? Well, you know, if it's even or if it's odd is a big part of this. So what if we just started with the algorithm for determining if a number is even or odd? Now, so that algorithm is here. So how can we modify this algorithm to match our goals, which is if it's an even number, we want to divide by 2, and if it's odd, we want to multiply by 3 and add 1. Well, instead of display, we could just, if it's even, we'll divide by 2. If it's odd, we'll times by 3 and add 1. Now, is that the full algorithm? Well, you notice the problem also involved iteration because you had to repeat until you reached the number 1. So we need to take that part that we have already and we need to stick it inside of a repeat until. And so you can see what we had before, and then you can see how it's in the repeat. Now, do we have everything that we need now? Or do we need to further adjust? Well, if you remember, we need to be able to display all of the numbers in the sequence. So the only thing we're missing is a display. So you notice at the very top, the first display is to display the original number. And then inside the repeat until, that display is to display the number after we have modified it. So display the rest of the numbers until we get to 1. So the question I want you to think about there is, how did using an existing algorithm help with the development of this algorithm? So knowing the algorithm for even and odd really gave me a great place to start. And it's less chance of errors if you have this existing correct algorithm. And then you can really focus on the how you're trying to modify it. So it's really a good place to start. All right. So I'm going to give you one and you can practice. So here's an example of an algorithm that you could follow to move the robot, which is represented by the triangle, into the gray square. Now, remember that the procedure goal reach returns true if the robot's in the gray square, and it will return false otherwise. So this algorithm works as intended. So here's the question for you. If I take out this black square, the algorithm no longer works as intended. It does not allow me to reach the gray square. So I want you to modify this current algorithm so that it will reach the gray square. So I want you to pause the video and work on how you might modify this algorithm. All right, let's see how we did, and let's see if you modified it the same way as I did. So first, I wanted to figure out, why did the algorithm not work on the right grid of squares? And so if you followed it, if you could move forward, you move forward, else you moved right. Well, it puts us in this big loop, and we're never able to get to the gray square. Now, if I'm going to get out of this loop to make it to the gray square, I know that I'm going to need to be able to turn left before asking if I can move forward. So why don't we go ahead and add that part in? So I asked the question, if you can move left first, and then you do that, and then you continue with the rest of the algorithm. So this rest of this algorithm is copied just as before. So let's see. We're going to just check the right grid to see if it works. So you get to here, and up to this point, it had, can you move left, has evaluated to false, but now it evaluates to true. So we look to see. Again, it evaluates to true here, but then we run into a problem, because if you check the algorithm, I've not reached my goal. I cannot move left, I cannot move forward, and I cannot move right. So I keep going through this loop, but I will never be able to move. So what's the problem? How can we fix it? Well, let's think about this. If we're, this last part, that should be our last resort. We've already asked the question, can I turn left? We've already asked the question, can I move forward? So there's really no need to check the condition if I can move right or not. I just need to turn right, because if I can't go left and I can't go forward, my only option will be to go right. So if you check, the algorithm so far gets to the same position, and then we're going to see if we still get stuck, because this is where we got stuck before. We couldn't move left and we couldn't move forward. So now it's going to tell us we're going to rotate right. Well, we still can't move left. We still can't move forward. So we rotate right again. Well, now we're able to make it to the end, and we're not stuck in the loop anymore. And then, of course, if you were to check, it would also work on the right-hand side. So why start with an existing correct algorithm? What benefits might we receive? All right, just as before, starting with a correct algorithm gives us a starting point. A lot of times, somewhere to start can be a challenge, and then there's less chance of making errors on the old part, right? So there's going to be less errors and less, when we test the algorithm, we have to do less testing on, because the part that we had before that works is still going to work. So modifying an algorithm that we already have that works is a great place to start. Now, I do want to pay attention to that last part though. How is modifying an existing algorithm different than copying an existing algorithm? So a lot of times we'll work as programmers with code, and we want to make sure that, like, sometimes we will reuse code, but in this case, just copying an algorithm, that's not what we're talking about here. Modifying algorithm is taking algorithm and changing it up so that it will meet our new goals. So there's a change that must be made there. And then remember that second grid of squares, that was like a new test case. So how does that make our program more, our algorithm more robust? Well, and now this will work for more cases than just the one that we started with. And so a good idea when you're making an algorithm is to try several test cases. And you may think, what further adjustments might I make to this algorithm? So what should we take away? You need to be able to combine, or you should be able to modify existing algorithms and be able to get them to work for your scenario. And and you need to be able to work with robot problems as well. Thank you.